reflected back toward its source, it forms a standing wave which appears to vibrate in place, like a guitar string. Hence, waves are being produced by the primary circuit and reflected by the zinc sheet. This is exactly what he wanted to find. Heinrich Hertz, professor of experimental physics at the Technische Hochschule in Karlsruhe, has made one of the greatest experimental discoveries in the history of science. He has proved beyond doubt the existence of electromagnetic waves. As Guglielmo Marconi and others were soon to show, the commercial value of Hertz's discovery was immense, but he had no notion of this, nor indeed of any practical application. What had captivated Hertz and set him on his quest was a beguiling but strange scientific idea, the brainchild of British experimentalist Michael Faraday in the 1830s, that had been raised into a full mathematical theory by the young Scot James Clerk Maxwell 3 decades later. Their idea was so different from anything that had gone before that many of the leading men of the time dismissed it as a flight of fancy. Others were simply baffled. They did not know what to make of it. But to Hertz, it was a beautiful idea that rang true. All it lacked was physical proof, and his quest was to supply experimental evidence that would put the matter beyond dispute. From the time of Newton, leading scientists had believed that the universe was governed by mechanical laws. Material objects held energy and inflicted forces. To them, the surrounding space was nothing more than a passive backdrop. The extraordinary idea put forward by Faraday and Maxwell was that space itself acted as a repository of energy and a transmitter of forces. It was home to something that pervades the physical world, yet was inexplicable in Newtonian terms: the electromagnetic field. Faraday's first notion of lines of force, much derided at the time, grew into Maxwell's sophisticated mathematical theory, which predicted that every time a magnet jiggled or an electric current was turned on or off, a wave of electromagnetic energy would spread out into space like a ripple on a pond, changing the nature of space itself. Maxwell calculated the speed of the waves from the elementary properties of electricity and magnetism, and it turned out to be the very speed at which light had been measured. He surmised that visible light is just a small band in a vast spectrum of electromagnetic waves, all traveling at the same speed, but with wavelengths that might range from nanometers to kilometers. All this remained just a theory, with more skeptics than adherents, until a quarter of a century later, when Hertz emphatically verified it by producing and detecting what we would now call shortwave radio waves in his laboratory. The door to previously unimaginable regions of scientific knowledge was opened. It is almost impossible to overstate the scale of Faraday and Maxwell's achievement in bringing the concept of the electromagnetic field into human thought. It united electricity, magnetism, and light into a single compact theory, changed our way of life by bringing us radio, television, radar, satellite navigation, and mobile phones, inspired Einstein's special theory of relativity, and introduced the idea of field equations, which became the standard form used by today's physicists to model what goes on in the vastness of space and inside atoms. Faraday and Maxwell have attracted their share of biographers, and rightly so. Aside from their genius, both were admirable, generous-spirited men who conducted their science with infectious enthusiasm and exuded the kind of charm that made people feel better about themselves and the world in general. But perhaps even more compelling than their individual life stories is the way that the two men from totally different backgrounds, a self-taught son of a poor blacksmith and a Cambridge-educated son of a Scottish laird, were brought together by their curiosity about the physical world and their determination to find out how it works. Although they met only late in Faraday's life, they formed a tremendously strong bond. They were united by their willingness to challenge entrenched